We're going to be graphing parabolas. We're going to start with the parabola that we are most familiar with. The parabola that we are most familiar with is y equals a times the quantity x minus h squared plus k, where hk is our vertex. hk is our vertex. And the sign that goes with k definitely is the sign that k is. So hk is our vertex. So I'm going to draw a vertex, and we're just going to say that that vertex is right here at the origin, just to make things easy. And A determines whether or not our parabola opens up or down. So when A is positive, the parabola opens up, and when A is negative, the parabola opens down. So I'm just going to start here with one that opens up. We don't really need to worry about the ones that open down. We've got enough experience. I don't need to draw both of those. So there's our parabola. Beautiful example of a parabola that opens up. Now, there are a few more parts to this problem. We've got an axis of symmetry. So we indeed have an axis of symmetry that goes right through the vertex. So I'm going to highlight that yellow. So our axis of symmetry, the axis of symmetry is an equation, x equals h. X equals h. I've run out of a little bit of room here, so I'm going to take what I've written and I'm going to just shrink it a little bit here. Let's see what we got. Let's see if I can grab all of that, and we're going to resize it. Beautiful. It's going to give me just enough room here to write what I need to write. So we've got this focus. So I'm going to draw it for dramatic purposes right here, just because I need to. So this is not necessarily accuracy. This is just a point, a location. That's called the focus. And the focus is at a point called xy. The focus is a distance. And this is why I said I had to put it where I did. It's a distance of 1 over 4a units from the vertex on, and it's on the axis of symmetry. Axis of symmetry. Then we have a directrix. These are parts of the parabola that you just never knew existed before, because it's not taught until you get to this class, or maybe even a higher level math class. They'll teach it in a pre-calculus class as well. So you've got your focus, and then you've got your directrix. So this right here is called a directrix, and the directrix is a horizontal line. So it's y equals some numerical value. I'll just put a pound sign. That stands for number, or at least it always used to before we started using them for hashtags. I'm going to shrink this, resize it a little bit. Okay. And then I'm going to come over here to the right, and I'm going to define the directrix for us. So the directrix is 1 over 4a. So that's a numerical value. It's 1 over 4a units from the vertex. And it's a horizontal line, and it does not go through from the vertex below, actually I don't want to say below, because if it's opening up from the vertex, not intersecting, that's a beautiful word right there, not intersecting the parabola. It's a horizontal line where y equals whatever that value is. And that's our directrix. So I'll just do a dashed line right there. And I'm going to highlight this, the directrix. There we go. Now let me just draw a picture of us with a parabola that opens sideways, just so you can see where these new parts are. You've got your vertex. Okay, so that's your vertex. And this time we've got a relation that fails the vertical line test. So it's not a function, it's a relation. This time our axis of symmetry is horizontal. So your axis of symmetry is horizontal. So it's going to be y equals, and let's write this down so you can see exactly what it's going to equal. So we're going to have x, let's start off with x equals a times y minus k quantity squared plus h. Now the vertex is still h comma k, but you can see where the h comes from and where the k comes from. If a is greater than 0, opens right, and if a is less than 0, it opens left. And here the axis of symmetry is y equals k. Isn't that nice? Y equals k. And then the directrix is going to be on the opposite side, and the directrix is x equals some number. That's our directrix. And don't forget your focus. Your focus is going to be like a little berry sitting in a bowl. So it's going to be kind of floating right there to the right this time, away from the vertex on the axis of symmetry still. So same definition applies. Same definition applies.